Chapter 5.3, Inverse Functions. Day 3, Finding Derivatives of Inverse Functions. Yesterday we talked about finding the derivative of the inverse function at a point. We would switch x and y, find the derivative of the inverse implicitly, and then plug in the appropriate point x or y, remembering to flip it from the original function. We also talked about how there's another way, is we could just find the derivative of the original function, find the value of the derivative at that specific point, and then take the reciprocal of that. So we're going to do our derivatives that way today. All right? And that follows this rule. G prime of x equals 1 over f prime of g of x. And we put the g of x in there to show that really we're looking at f prime of y from the original function. All right? So here's how this works. Okay, verify that it has an inverse. Look to see it's monotonic, meaning always positive or always negative. We'll do that first. We'll take the derivative, f prime, bottom, derivative of the top minus top, derivative of the bottom over bottom squared. So x minus x is 0. Negative 2 minus 6 is negative 8 over x minus 2 squared. Only critical number is 2. And since the bottom is always positive because it's squared, the top is always negative since it's negative 8, we can see that this is always decreasing. So this function's monotonic, so it has an inverse. All right? Then let's find the value of f inverse prime of a. Well, a is 3. Since that's the x in the inverse, it's the y in the function. So set the function equal to 3. All right? Like I said, you can do some plug and chug. If I throw in 0, I get negative 6. If I throw in 1, I get 7 over negative 1. Let's try negative 1. Well, let's try a calculator here. X plus 6 over x minus 2. We'll go to our table and just start trying some values. I'm looking for 3. It's always decreasing. 6. F of 6 equals 3. Therefore, f inverse of 3 equals 6. All right? So what I can do is plug in 6 into the original function. Right? If I plug in 6 into the original function, I get f prime of 6 equals negative 8 over 6 minus 2 is 4 squared is 16. Negative 1/2. If I flip it, f inverse prime of 3 then would be negative 2. As you find the derivative of the function is the same as the derivative of the inverse at the corresponding point. And 6/3 on the inverse is 3/6 on the function, or 6/3 on the function is 3/6 on the inverse. All right, try this one. Let's skip, well, no, we got time. Let's verify it has the inverse first, so we need to show it's monotonic. Since we got to find the derivative anyway, that works. So we'll find, let's rewrite this as 4x to the negative 1. So our function is 3x squared plus 4x to the negative 2. We'll write it like that. Our critical numbers are 0. Let's see here. 3x to the 4th plus 4 over x squared. Critical number is 0. It's always positive on the top. It's always positive on the bottom, so it's monotonic because it's always increasing. And we can see when the function equals 6, 6 equals x cubed minus 4 over x. Let's try 1. We got 1 minus 4. Nope, let's try 2. That's 8 minus 2. So f of 2 equals 6 means f inverse of 6 equals 2. Well, we're looking for the derivative of the inverse. First, we find the derivative of the function, which we did to show it's monotonic. Plug in 2, f prime of 2. Well, we got 3 times 2 squared. That's 4 times 3 is 12 plus 1 is 13. F prime of 2 is 1. So f inverse prime of 6 is 1/13. Right? Another way to look at it. Again, I try and keep and do it the way I showed you yesterday, so you don't have to remember a formula. You remember the concept of inverse, meaning switch. And you just switch everything and go implicitly. All right? Verify this has an inverse again. We're going to need to find the derivative anyway. So let's rewrite this as x minus 4 to the 1/2. Our derivative is 1/2 times x minus 4 to the negative 1/2 times the derivative of what's inside, which is 1. I'm going to rewrite this as 1 over 2 square root of x minus 4. All right, this has a domain. It has to be 4 or larger. So our critical number being 4 is kind of like an endpoint. And since there's only one endpoint and it doesn't switch signs anywhere but at the endpoint, this is monotonic. And we can double check it, throw in 10. We can see this is positive, so it's always increasing. Okay. Now we want to see where is the function equal to 2. So we'll take 2 equals to the square root of x minus 4. This one's easy to solve. We'll square both sides. And x equals 8. So f of 8 equals 2. That means f inverse of 2 equals 8. So if we're looking for the derivative of the inverse at 2, we need to find the derivative of the function at 8. Right? F prime of 8 equals 1 over 2 times the square root of 8 minus 4, which is 4. So that's 1 over 4. So that would be f inverse prime of 2 would be the reciprocal of that, which is 4. Okay? So in conclusion, to find the derivative of the inverse of a function, 2 ways, really 2 options. Right? First option, 1, switch x and y. 2, derive implicitly. 3, plug point and solve for y prime. All right. Excuse me. Second method, 1. Find y prime for the function. 2, plug your point. 3, take reciprocal of your derivative. Okay, so there's really 2 ways of looking at it. They're both relatively straightforward. The same concept. One, you're taking just a different alley to get that.